Hello boys and girls, welcome to the answers to portfolio questionnaire number 3. Let's get to it. Questions 1, 2 and 3 can all be dealt with in one go. Incidentally, all the questions for this portfolio are based on the graph that is shown there, which is showing the some revenue curves and cost curves for a firm operating in the short run. Remember that the short run means a situation in which the firm can't change some of its inputs into the production process. And normally we would say, as to illustrate the idea, that we say there's two inputs. One of them is capital, machinery, and a factory and so on, and the other input is labor, and we'll say that labor is variable, can be changed. You can add more workers to your factory in order to produce more output, but the capital can't be changed. It's fixed. All right, so that's we're dealing with the short run with these curves for this firm. All right, so you label the curves. Well, that's pretty straightforward. The first curve is the marginal cost curve. The second curve is the average revenue curve, or from the perspective of the consumer, the demand curve. And the third curve is the marginal revenue curve. Easy. Next. Question 4. After output level 7, curve 1 slopes upwards because of the law of diminishing marginal returns to a variable input. True or false? That is true. Remember that the law of diminishing marginal returns, which applies in the short run to a firm, says that after some point each additional unit of labor, the variable input, contributes less to total output than the previous unit. Each additional unit of labor is, in a sense, less productive than the previous unit of labor. And that's not because each additional unit of labor is stupider or lazier or more tired or less skilled than the previous unit. It's simply a function or due to the fact that we're dealing with the short run. We're dealing with a fixed size factory with a fixed number of machines in it. You keep adding workers to this factory, eventually the workers are going to start running out of things to do, basically. So they will be able to contribute less to total output than the previous workers. Okay, so that law implies that if you want to increase output by constant amounts, the firm wants to increase output by constant amounts, because after some point each additional unit of labor is less productive than the previous unit, you'll have to employ more and more additional units of labor, which are less and less productive, in order to get this output to keep going up by the same amount. We can see this with a little bit of mathematics, so don't be frightened, it's pretty straightforward. Marginal cost is equal to the change in total costs divided by the change in output. It's the change or the increase in total cost due to increasing output by a very small amount, say 1 unit. Alright, so far so good. Then we can say, well, what's the total cost made up of? Well, we know total costs are made up of total variable costs and total fixed costs. So marginal cost equals the change in total variable cost plus total fixed costs due to increasing output by 1. Okay. And then we can say, hang on a sec, the total fixed costs, what are they contributing to the change here overall? Well, nothing. Total fixed costs are, as the term implies, fixed. They don't change, which means we can drop this out. So we're just left with marginal cost equals the change in the total variable cost due to divided by the change in output by, say, 1. Then we can ask, Alright, well, what's this total variable cost made up of? How do we calculate that? Well, total variable cost is the amount of labour employed multiplied by the wage rate paid. Okay, you employ more workers, you pay them all the same wage, then your total variable costs go up. Alright, so the change in labour multiplied by the wage rate divided by the output gives you marginal cost. Oh my god. See, this is the wonders of living under a flight path. Actually, that was a helicopter. A police helicopter, because I live in a very stabby suburb. Marginal cost, we can then rearrange that as the change in labour over the change in output, and we can just put the wage rate to the side. It's still there, we're just putting it's just rearranged a little bit. Alright, so let's take that. Now let's put a little hat over the top of, or a little bar over the top of the wage rate to indicate that we're holding that fixed. We're holding that constant. The wage rate remains unchanged, whether we add more workers or not to our factory. Alright, now, remember what is implied by the law of diminishing marginal returns. The law implies that if we increase by output by a given amount, say by 1, so we go from 10 to 11 for example, then we'll have to add more workers. And then if we increase output again by the same constant amount, so we say go from 11 to 12, we'll have to add even more workers. Right? These are more additional workers. Why? Because the law says that after some point each additional worker is less productive than the previous worker, so we'll need to employ even more of them than before. If we increase output again by a constant amount, we'll have to employ even more additional workers. And up again, even more additional workers. Alright, so what's happening to this ratio here, which is showing really the marginal cost? What's happening to that ratio? The denominator is rising faster, continually rising faster than the numerator. So what's overall happening? It's going up. And that's what's happening to the marginal cost curve. So there you go. Question 5. Curve 1 will always intersect at the lowest point on the average total cost curve. True or false? Well, that's true. And we know that because this is just a mathematical relationship between averages and marginals. So wherever the marginal cost is less than the average total cost, it drags the average down. Wherever the marginal is less than the average, it drags the average down. And when the marginal cost is greater than the average, it drags the average up. Now, if that's the case, then the average is being dragged down because the marginal cost is less than the average, and it's being dragged up because the marginal cost is greater than the average. There must have been a point at which the average cost turned. Right? There was a turning point, and in fact it was its lowest point. Where would that have to be? Well, it would have to be where the average cost equaled the marginal cost. Okay? That would have to be the average total cost's lowest point. Alright, next. Question 6. The profit maximizing output cannot be determined from the graph. Well, that's just false. We can determine the profit maximizing output from this graph. Remember, our behavioral rule for a rational firm is that it will keep increasing output wherever the marginal revenue is greater than the marginal cost. That is to say, it will keep increasing output while ever the revenue from the next unit produced would be greater than the cost of producing that next unit. So keep doing that up to the point where the revenue from the next unit produced is just equal to the cost of producing that next unit. Don't produce beyond that. Or in other words, produce up to the point where the marginal revenue just equals the marginal cost. So we can easily see the optimal output for our firm on the graph. It's the point at which the marginal cost and the marginal revenue intersect. That's where they're equal. So the optimal output will be 7. And we know that we can show that this firm is making a profit, and it must be the maximum profit because it's producing at the optimum point, by using the rest of the curves. The firm will charge the highest price consumers are willing to pay, as determined by the demand curve. So consumers are willing to pay $450 for 7 units. And that's the price the firm will charge. So the firm will make revenue of $450 per unit. What's the cost per unit to the firm? Well, that's given by the average cost curve. Average cost means the cost per unit. So that's $325 per unit. Alright, so we know the firm is making a profit. They're making profit per unit. They get revenue $450 per unit. Their costs are $325 per unit, so they're making $125 profit per unit. So then all you have to do is say, well, if it's $125 profit per unit times 7 units, that will give us our total profit, and that will be the maximum profit. So average revenue minus average total cost gives you the profit per unit, times the quantity produced gives you your total profit. 450 minus 325 is $125 profit, times 7 units produced gives you $875 profit. Easy. Incidentally, if you want to see an example of a profit maximizing firm in popular culture, I recommend to you the movie Sorry to Bother You. It's an excellent movie. Question 7. If wage rates fell, then curve 1, and curve 1 is the marginal cost curve, and the average total cost curve would shift downwards. True or false? True. Let's look at marginal cost first, and I'm going to again illustrate this with a little bit of maths. You'll remember from the previous slide that we can represent marginal cost as the change in labour over the change in output times the wage rate. Now, in this question, we want to say that the wage rate falls. So what's going to happen to the marginal cost? It's going to fall as well. And we can represent that on the graph by shifting the marginal cost curve downwards. Alright, what about the average total cost curve? Well, we know average total cost is made up of average variable cost plus average fixed cost. And we can rewrite that, it's the same thing, it's just how you calculate the averages, in this way. The totals over the total cost over the total quantity, which gives you the average total cost. Total variable cost over quantity plus total fixed cost over quantity gives you average variable cost and average fixed cost. Okay. Now, what we're looking for is wage rates. So where's that? That's going to be inside here, the total variable cost curve. Sorry, total variable cost. So average total cost equals average variable cost, where average variable cost is total variable cost over quantity, and total variable cost is the amount of labour employed times the wage you pay each unit of labour. So if we decrease that, decrease the wage rate, what's going to happen to the overall average variable cost curve? Average variable cost, it will fall. Assuming nothing else changes, this will fall. And so what will happen to the average total costs? They will fall. How do we show that on the graph? You might ask, why do we shift the curves downwards in this case? Why are we shifting the whole curves? Because here we're talking about if the wage rate changes, independent of output, independent of the output, then how would we represent it? See, if the output were 3, then, and the wage rate fell, even though the output didn't change, the costs would be lower. Okay? The cost would be lower. If the output were 7, then the costs would be lower. If the output were 14, then the cost would be lower. So the change in the wage affects the costs, whatever the output level happens to be at any given point. That's why we shift the curves down. Question 8. Curve 3 should be twice as steep as curve 2. Curve 3, the marginal revenue curve, should be twice as steep as the average revenue curve. That is true. In order to demonstrate that that's the case, we could do it 2 ways. One is we could do it by means of an Excel spreadsheet, and you can do that yourself, and you'll be able to see that. The other is by calculus, but we don't really have time or space for that, so we're just going to have to take it on faith. It's in the textbook anyway, so you can figure out what the answer would be that way. Maybe I'll make another video showing how by calculus you can show that the marginal revenue curve has twice the slope of the average revenue curve. But for now, it's true. Question 9. Curve 3 represents the law of demand. Well, that's false. It doesn't represent the law of demand. The law of demand is represented by, that's marginal revenue curve. The law of demand is represented by or reflected in the average revenue curve, not the marginal revenue curve. In question 10, the downward sloping position of the average total cost curve reflects economies of scale. So average total cost, so that when the curve is downward sloping like this, that's reflecting economies of scale. True or false? False, because economies of scale apply in the long run, not in the short run, by definition. And the long run is where you can change the scale of the production operations. In the short run, by definition, you can't change the scale of operations. And you can't employ more of all of the inputs in the short run. So this is false. It doesn't apply because we're talking about the short run here. That is that for the answers to the portfolio questions. Have a wonderful time studying.